today we'll go through what all we are going to cover in this particular course. All right. The details about the course, the topics, the sections that we'll be covering in the course, and obviously the details as to why data engineering is becoming so important and why you should upskill yourself with data engineering on Azure. Right. So I hope everybody knows what data engineering basically means, right? And the data roles which are available for you, right? So if you want, you can just imagine a huge pile of Lego bricks, right? So Lego bricks are those small bricks that come for kids, right? And the kids generally they build a bigger statue or something out of those small bricks. So that is the Lego game that we've all played in our childhood, right? So if you consider those bricks to be scattered all over the floor, right? Now, your goal over here is to do something or to build something awesome, right? Like, let's say, a spaceship or a castle using those bricks. And before you can start building, the first thing that you need to do is to sort those bricks, correct? You need to sort those bricks by color, by size, by shape, and you do that so that it becomes easier for you to find a particular piece, a particular color, right? A particular size, if and when you require it. And that is exactly what data engineering is, right? It is like sorting those and organizing those Lego bricks. But this time we are not working with Lego bricks, we're working with data, right? So data here is like those Lego bricks scattered all over, right? It comes in all shapes, sizes, formats. It could be number, it could be text, it could be a picture, it could be anything, right? And data engineers are the people who are going to organize this data, right? They're going to clean it up, they're going to sort it, and they're going to make sure that it's stored in a way that it is easy to access for everybody, right? So the organized data is like the sorted Lego bricks. Now it's ready for someone else, right? Somebody like data scientist or data analyst to come and start working on that data, right? So the job of data engineer is to take the data in the raw form. Just give me a second. I'll just connect my tablet. While that is loading up, right? In short, data engineering is all about making raw data useful, right? Data coming from various sources in various formats, and all you have to do is make it usable, right? Bring it to a format where everybody can use it. You can make some sense out of that data, right? So basically, the process of converting structured data, we call it, right? Because structured data is the format that we want to achieve. This is what generally we want in order to do the analysis on the data. You may store this structured format in something called as a data warehouse, right? The raw data may be present in the data lake, and that is all that we are going to study, right? So the entire course will focus on this journey of collecting raw data and then bringing it to a unified format by cleaning it, by formatting it, by filtering it. And along the way, we are going to see a lot of different tools that we're going to use to perform these particular transformations, right? So welcome everybody to this course. I will just quickly give you a few details about what you can expect from this course. Now, this course will last for almost more than 35 days, right? The duration in hours is more than 45 hours. We will have more than 45 hours of lecture spread across more than 35 days. The timing would be around 8 p.m. to 9 p.m., but generally it will go until 9:15, 9:20, 9:30 in some cases as well, right? Apart from that, you will also get hands-on lab support from Microsoft. All right. These are the labs which are curated and created by Microsoft and their partners. So you will get access to these labs from us, right? So you will have complete hands-on support that Microsoft is giving out for the students to perform all these particular or to try out these tools, right, in real life. So you don't need an Azure subscription in that case. We will have these labs to perform the or to work with the various tools which are there, right? So these will be guided labs. I'll talk about the labs in a while. We'll talk in detail about these labs. Apart from that, towards the end, you will also have two hands-on projects which you will need to implement, right? These are end-to-end projects. One project will be containing various Azure services, right? So here you will have services like Data Factory, you will have SQL Server integration, right? Data Factory to get the data from the SQL databases. Then you will be using a self-hosted integration runtime in order to make that Data Factory instance work. Then you will have the data lake, right? You will have the medallion architecture, you will have Databricks to format that data, and then finally we'll put all of that data into a data warehouse and then visualize that data. So that is going to be the end-to-end hands-on project number one. And the second project is a complete Databricks project. All right. Considering the amount of interest that the companies have recently shown on Databricks, right, and the buzz that has been created around Databricks, and not just any buzz, like it's basically deserved, right? Databricks is a service that allows you to do a lot of things with a lot of efficiency, right? So we'll try to focus more on Databricks. We'll try to do more hands-on with Databricks so that you can, easily claim that you have expertise knowledge when it comes to Databricks. Apart from this, apart from the labs, the hands-on project, the course, you will get PDF learning content for each topic that we are doing, right? So every day, day-to-day basis, you will receive these PDF learning documents so that you can use them in a future date to revise, or if you want to, go through the content, you can do that. On top of that, we'll also share interview questions from each section, right? So when I say each section, we'll discuss what these sections are in the next slide. And then obviously the resume support, where we'll help you build a perfect resume, or to build a resume where you can showcase your data engineering skills, right? So this is the entire package for the course. This is what we are going to cover, right? This is what we are going to have. Now, when I talk about the section of this particular course, so this course is divided into 8 broad sections. All right. These are broad sections because we will start a journey with the fundamentals of Azure, right? So now I assume that most of you are new to Azure. Do we have people here who've worked with Azure before? All right, so some of you have worked with Azure, but I will assume that most of you have never worked with Azure, right? You do not even know what cloud computing is, and that is from where this course will start. All right, so this Azure fundamentals section, the first section, it's going to be a big section where we discuss the fundamentals of Azure. We'll see what cloud computing is, what are the different cloud models, what are the different cloud services, uh, right? Services as in your infrastructure as a service, platform as a service, software as a service. And when you talk about cloud models, we'll see what is private cloud, what is hybrid cloud, what is public cloud, right? And then we'll move towards the core architectural components of Azure. That means how Azure is built, right? We'll try to understand what are the basic building blocks of Azure. How do you create a data center? What all goes inside a data center? What is the nomenclature that we use for the different sections within the data center? Then how do those data centers combine to form a region? How do regions combine to form a geography, right? If you have a region, what is a region pair? All of that we'll try to understand. And then obviously, uh, we'll try to understand how you'll create resources within Azure. What is a resource manager? What is an ARM template, right? What is your resource group, subscription, uh, management groups? All of that we'll cover under the fundamental section. And then some basics of Entra also we'll see, right? So Microsoft Entra, or Azure Entra ID, is your Microsoft's ID and authentication providing platform. All right. So it is an identity and authentication providing solution from Microsoft. So we'll cover the basics of it. We'll try to understand how you create managed identity and all, so that when we work with various other resources, we can give access using Enter ID to those resources, to some other resources. Now, it may not make sense right now, but when we do it, you will understand why is it needed and why are we implementing it. then some security features, and then we'll move away from the fundamentals part once you have the core understanding, right? Uh, Next, what we'll do is we'll work with Azure data fundamentals, right? Now, when you are fully, you know, clear with what Azure fundamental is, right? Or what are the basics of Azure, once you have that understanding, once you have the knowledge of how you're going to work with Azure, that is where we'll start now working with data fundamentals. We'll try to understand what all different types of datas are there, right? For example, your structured, semi-structured, unstructured data, how Azure stores these different types of data, right? For example, structured data will be stored in SQL databases or wherever, right? Then your semi-structured data will be stored in a Cosmos DB, right? Then you have unstructured data that can be stored in a storage account or a data lake. That we'll try to understand in data fundamentals. We'll try to see what a storage account is all about, what a data lake is, how is a data lake different from the storage account, what are the features, what are the benefits that a data lake gives you over a traditional storage account, right? The directory structure, the POSIX compliance, all of that we'll cover. Then we'll also see the basic of data fundamentals in terms of what all services are available, right? Here we'll not go into each of the service in depth, but when you have the idea of how data is stored in Azure, once you have the idea of data lake and everything, in data fundamentals, we'll also see the SQL database and the NoSQL databases which are available within Azure, right? So your SQL database and the Cosmos DB. Then we'll move towards the core data engineering services, I should say, or tools within Azure, right? So the core tools that we are going to cover in this course is Synapse, Data Factory, Stream Analytics, and Databricks. Clear? On top of this, we'll have a brief discussion on something which is very new, right? Not adopted by a lot of organizations as of now, but in the near future, all you will hear from Microsoft would be about Fabric. So we'll try to see what is Microsoft Fabric as well. So these are the five core services from Microsoft or from Azure that we are going to cover. When we start with Synapse Analytics, we'll try to see what is the serverless SQL pool, right? We'll see what is a dedicated SQL pool. We'll see what is a Spark pool, right? So different pools that the Synapse offers, where your dedicated SQL pool is nothing but your SQL data warehouse, right? So what is the data warehousing solution in Azure? That is a dedicated SQL pool present within your Synapse Analytics. All right. We'll try to see how you can do exploratory data analysis using serverless SQL pool where you do not store anything. Then we'll see how you can then create persistent tables using the dedicated SQL pool. And then this particular part of Spark pool, we'll keep it towards the end, right here. Why so? Because before we work or before we start working with the Spark pool, there are a few things that we need to know. First, the basics of Python and PySpark. Second, PySpark will be used to talk to the Spark architecture, right? So interchangeably, we'll study these two topics, right? PySpark and Spark architecture and Python. And then we can start with Spark Pool and Databricks. Because Databricks is what? Databricks is also built on top of Apache Spark. All right. Once we are done with Synapse, we'll see how you create pipelines in Azure. All right. Or data flows. So mapping data flow and everything we'll see here in Data Factory, right? Apart from that, we'll see self-hosted integration runtime, right? So I'm just taking these names so that if somebody is aware of them, they may know, right? We'll talk about Git integration, right? Of Data Factory with GitHub, right? How do you integrate Azure Data Factory with GitHub? Why is there a need to integrate Azure Data Factory with GitHub, right? So all of those things we'll see. We'll see the pipelines. We'll see different types of transformations that you can do with the pipelines. We'll see mapping data flows. We'll see how you can create a fact table, right? Using Data Factory, how you can create a dimension table. All of that we'll see. Then we'll move towards something which is becoming really important these days, and that is your stream processing. Streaming data processing solutions are becoming really popular today, and Azure provides a dedicated service called Azure Stream Analytics to deal with streaming data. All right, this means Azure Stream Analytics is a service that basically deals with real-time data which is processed, within minutes, within seconds. For example, today, if you want to do a bank transfer, you do NEFT, you do RTGS. Those are batch processings, right? Because what happens there is uh, the data is received by the bank and it is processed in a gap of every 30 minutes, right? So it's processed in a batch of every 30 minutes. But if you do UPI, that is your stream processing. Why? Because the moment you do the UPI payment, the transaction is processed within seconds. That is your real-time data processing. So to how to process this real-time data, we'll try to see in Stream Analytics. Not just the Stream Analytics service, we'll also see a real-time data management service called Event Hub. We'll cover Event Hubs also here. Then we'll move towards the basic of Python, the basic of PySpark. What is PySpark? What are these, Spark APIs or the data frame APIs that we talk about? What is a Spark table? What is a Spark data frame? Right? What is the Spark architecture? Right? The worker and the driver and the worker, or the driver then the executor relationship. What is cluster manager? Right? All of that we'll see. What is a Spark session and everything, all the relation between all these different things we'll see. Then with using the Spark, right? In the Spark pool in Synapse, we'll using PySpark and the Spark architecture in the Spark pool in Synapse, right? Basically, Spark pool is a service, or a service within Synapse that offers you the Spark architecture, right? So you can create the Spark architecture within Spark pool and then work with it using PySpark, right, to process the data. So that we'll see in Synapse. Then we'll come to Databricks. Within Databricks, we are going to see a lot of things. All right. Within Databricks, we'll see, first of all, what is Databricks? We'll see how you set up a Databricks environment. Then we'll see the medallion architecture, the Unity catalog, right? Different types of transformations using PySpark, right? How do you connect to different sources? How do you mount uh, this ADLS, right? All of that we'll see within Databricks. So as I said, we'll end with the Databricks. We'll see, different types of analysis, the utilization of the medallion architecture, what it is, creating visualizations within Databricks, right? How do you access data lake? How do you mount data lake to DBFS? What is Databricks file store? What is Hive metadata store, right? Metastore. Uh, and then what is the lakehouse architecture, right? All of that, Delta Live tables, and then finally the CI/CD with Databricks. All of that we'll see within our Databricks section. All right. So these are the core sections of the entire course, and these are the topics that we'll be covering. All right. Now, moving on, uh, some details on the hands-on lab, right? So these labs are provided by Microsoft themselves, right? There is a partner from Microsoft called Scalable who are going to provide these labs to us. So there will be 22 labs in total, right? So 22 different scenarios, basically covering different topics, right? For example, data lake or Synapse. There will be a lot of labs from Synapse. There will be a lot of labs from Databricks, Stream Analytics. You will find labs, right? So labs from various data engineering topics within Azure. Each lab comes with 10 launch attempts, right? So you can launch each lab 10 times to practice, right? Each single lab session will be valid for 2 hours. Therefore, each lab could be launched for 200 hours. All right. So these are the guided labs. Apart from guided labs, we have a few challenge labs also, where you may not find the guided instructions that you're looking for. These are the labs that you may have to perform on your own, right? And the labs will be valid for 60 days, right? So you will be given the labs once you're done with Synapse, right? I will not give you the labs once you're done with the data or in the beginning itself, because I know that it's not the ideal time for you to start practicing, at least when we are done with Synapse over here, right? This is where post section 3, you can start working with the labs, correct? So then You will find labs on Synapse. You'll find a few labs on Data Factory, some on Stream, uh, SpicePark, and Databricks, right? You'll find a lot of labs here. I have a few, details about, why data engineering, what is the market like, what is the trend like. So let's discuss those things before we get into the questions and answers, right? So there are a few reports available online, right? And according to them, in most of the job postings which are available online, right, with respect to data engineering, most of them they demand SQL. Yes. So I'm sure you can see in your screen, SQL is there. Azure is also there. Now, some of you may have your, concerns regarding whether Azure or whether AWS or should I go for GCP. Now, currently, AWS has the biggest market share, around 30-31%, right? Second is Azure with around 26 or 27%. And then we have GCP around 10%. That is what the market share currently is in the market. The problem is for AWS is that AWS is a declining market. All right. AWS is losing its market share every year, whereas Azure is gaining market share over AWS. Right. So therefore, Azure data engineering, Azure as a technical skill, along with the data engineering tools, is something that you should go for. ETL, Apache Spark, Data Lake, all these are common keywords that you can find in almost every job opening which is available online, right? Then, if you talk about the programming languages that they require, right? SQL and Python. Now, SQL is something which I expect everybody to know beforehand. We are not going to be covering SQL here, right? So my expectations from everybody who becomes a part of this particular course is that SQL is a prerequisite. All right. And if you don't know SQL, that's fine, right? Why? Because the initial few days or a couple of weeks, right? That is where we'll be focusing on the Azure and the data fundamentals, right? Or data fundamentals in Azure. So you have those 2 weeks to brush up your SQL. If you've already worked with it, if you've not worked with SQL before, this is your time to study SQL, right? It will not take a lot of time. You can complete a good amount of SQL. You can gain a good amount of SQL knowledge within a week, right? So that is something that you have to do. The second thing is Python, right? Now, Python is mentioned here, but PySpark is eventually something that I want everybody to learn, right? If you want to become a successful data engineer, Spark and PySpark is something that you should know. All right. So I will do the basics of Python in the class, and I will also do the basics of PySpark in the class. And within this section, when we are working with Databricks, right? The moment we start working with Databricks, I will give you a lot of sample codes, right? Uh, Pertaining to different things that you can do with the data, right? For example, if you want to read the data, what is the PySpark code for it? What are the different options available to read the data? What are the different methods available to read the data? All of that. Then, if you want to write the data, what are the different methods in which you can write the data? So, a file for that. Then, a file for, let's say, transformations, right? Reading the columns, selecting columns, renaming columns, all those transformation, then filtering a separate file. So like that, I will give you file by file code to work with the data using PySpark, right? Whatever transformation you want to do, or you want to, work with the data lake, you want to mount data lake, all of that code, I will give it to you topic wise, right? Then you talk about the cloud skills which are required currently, right? So the current market study that I was talking to you about, right? About the open jobs in the market. Now, you can see that around 74.5, so almost around three-fourth of the job openings have Microsoft Azure as a required skill, right? So this is your, this is the reason as to why you should work with data engineering today, right? Uh, I will now present you with some facts and figures, right? I know it may become overwhelming, but these are actually collated from various studies that we've seen, right? So in today's data-driven world, right, data engineering, it has emerged as one of the most sought after careers, right? And you have a lot of organizations which are, increasingly relying on data to make informed decisions. And that is why there is a huge demand for skilled data engineers, right? The demand has skyrocketed. So when combining with Microsoft Azure, which is again a very leading cloud platforms, right? Data engineering becomes even more powerful and rewarding for you. All right. So why why data engineering? Obviously, there is a demand for data engineers, uh, according to a report by LinkedIn, right? LinkedIn's emerging job report. I think it's a year old report which is available, right? Data engineering roles have grown by 35% annually, right? So it's one of the most fastest growing tech jobs which is available outside, right? And it is projected to grow almost by 28 to 30% up until 2030, right? Much faster than the average of all other occupations which are available, right? And that is why companies are investing heavily in data infrastructure. And Azure is the platform that is leading, right, to build these scalable data solutions. The second reason is cloud platform. I think there's some problem with the PPT. It's not, I made a mistake there, right? So the second point is cloud platforms for data engineering, right? So using Microsoft Azure, which is obviously one of the top cloud platforms globally, uh, Azure will provide a comprehensive suite of tools, I would say, for data engineering. Something that we've already discussed: Data Factory, Synapse, Databricks, Database, Cosmos DB, right? So these tools, they make Azure a one-stop solution for building your end-to-end data pipelines. That makes it easier for data engineers to work efficiently, right? Uh, then you have higher salaries. Data engineers are among the highest paid professionals, right? If not the highest, they are. There's a lot of demand, and there is a very less, I should say, supply of skilled data engineers. All right. So Azure data engineers itself is a high paying job. Data engineers with Azure, right? With Azure expertise, obviously, they command even higher salaries for it, right? Now, real world uh, applications and industry adoption, it is huge for Azure, right? Azure as a cloud platform is used by 95% of Fortune 500 companies. Giants like Walmart, BMW, Samsung, they're all relying on Azure for their data engineering needs. All right, so that creates a massive demand for Azure skilled data engineers. All right, for example, Walmart uses Azure to process almost 2.5 petabytes of data every hour during peak shopping seasons. All right, and there's also a big shipping company, Maersk, right? I'm not sure if everybody has heard of it, right? They use Azure Data Factory and Synapse Analytics to optimize their supply chain operations, right? Which obviously helps them to save millions of dollars annually, right? So you are just future proofing your career, right? The cloud computing market again is expected to grow to almost 1.2 trillion by 2028, right? According to the Fortune Business Insights. And as more companies they migrate to cloud, right, the demand for cloud-based data engineers, or the cloud-based data engineering skills will only increase, right? So what is happening today? You see that most of the companies are directly, hosting everything on the cloud, or the older ones, which earlier had their data present in a physical server in their own data centers, they are migrating to Azure, right? And Azure has also launched new innovative tools such as Purview for data governance, right? Machine learning for integrating AI to your data pipelines, right? So by learning Azure, you'll stay ahead of the curve in a very rapidly evolving industry over here, right? Then Microsoft also offers a wealth of resources that you can use to prepare to learn uh, Azure as well as data engineering. All right. And Azure, as we said, is used by organizations worldwide. So that gives you the flexibility to work in any industry, in any region, right? You have a lot of remote work opportunities also for data engineers, as cloud-based data engineering tasks can be performed from anywhere, right? So in the end, you'll be doing some impactful work. As a data engineer, you'll play a critical role in transforming raw data into actionable insights for your organizations, right? To drive business, to drive smart decisions for the business, right? Then why just, whatever we discussed, it's the global view of how data engineering looks in the near future, or what it looks like, what the market is going to be like, right? But why to pursue data engineering in India, right? Especially for people in India, right? Uh, so the job market in India is also booming, right? There's a rapid digitization of industries, right? There's a rapid adoption, huge adoption of cloud technologies, and there's an increasing reliance on data-driven decision making. Almost every organization today wants to make decisions based on data, right? So who's going to supply them those data, right? That they want to work with. So that data is going to come from a data engineer, right? Because that data has to be in a proper format, in a readable format. It is clear of any noise. It does not have any null values. It is filtered. Only relevant columns are present. All of that a data engineer has to do. Clear? All right. Then India is also emerging, not emerging, I think it has become a global IT hub, right? In terms of services, right? Data services, data engineering services, data analysis services, right? So data engineering has become one of the most promising career paths, right? Uh, if we talk about the same stats, right? The India's data analytics and data engineering industry is expected to grow with a annual rate of 28%, right? To reach around $120 billion industry in 2026, right? And the demand for data engineers has surged in India by 40% year on year, right? That makes it one of the most fastest growing tech roles in the country today. And companies across sectors like IT sector, e-commerce, healthcare, finance, manufacturing, right? They're all actively hiring data engineers to build and manage their data infrastructure, right? You get good salaries as well, right? Professionals with expertise in cloud platforms like Azure, AWS, or Google, they command even higher salaries. And adoption of cloud technology in India is really good, right? India is one of the fastest growing market for cloud computing, right? And the Indian public cloud service market is expected to reach around almost $15 billion by 2026, right? Growing at an annual rate of 24%. So Microsoft Azure is leading the cloud platform in India. It is used by major companies, TCS, Infosys, Reliance, Flipkart. They're all using your Azure, Microsoft also. And these companies, they rely on Azure for building scalable data pipelines to build analytics solution, correct? So that is, one of the reason as to why you should pursue data engineering here, with this course. So I hope uh, I'm assuming that you'll all have a lot of questions to ask. So why don't you just go ahead and we can have a small Q&A section before we move to the demo.
Maybe I'll go first. So I have
Yeah.
a few questions. One is about Azure account. I
Mm-hmm.
try to do self-learning by myself. So I, sort of done using all my cards and this and that. So do we get Azure account, provided from here?
See, we do not provide Azure account. You will get labs to practice. Those labs will have Azure subscription, but then those are guided labs. So you cannot use it for any other POC work that you want, right? Apart from that, I can help you to create Azure free accounts where you can do your side work, whatever you want to, learn on your own. So I hope you know that Azure free account gives you a $200 credit, which is valid for 30 days, right?
Yeah, so that it is usually what happened. I did not explore much, but then it got expired. So that's how I ended up like creating and then not using, creating, not using. It went in that way. So that's one. Second thing is, I was just comparing the cross criteria you have given and what I have given from the PDF. So both
Mhm.
are same, right?
The criteria as in the content you're
The
talking about?
syllabus for
Yes.
this course, both are same, right?
Yes, yes, both are same.
Okay. And then the third question is, um, I do come from a data engineering background and I am switching to cloud. Though I know all these services and this and that, more of I want discipline learning so that I can answer all the technical questions, which means I'm aware of all the data modeling concepts, data architecture concepts, but I'm not able to imagine or visualize with the Azure environment so far. So, are we going to talk about Azure data architects and Azure data engineers' roles and responsibilities? Because what we have seen is like so far tools, and probably I assume how are we going to work with the tools and stuffs, but how that is going to be in real time projects.
Yeah, so see, when you talk about just tools, right? Uh, that is not a comprehensive understanding of everything if you surround it around the tool, right? There's a lot of things happening around the tools also. For example, governance, for example, security, right? So to
Yeah, for
become a
governance purview and all, I did not
Mhm.
see. So I had a like sort of question. Will purview will be also covered because that's
Yes,
under
so we'll
governance
cover the
as well.
basics of purview, yes.
Mhm. Okay.
And when it comes to security, there's a completely different section on data security. And throughout the course, right,
Mm-hmm.
when we're working with Synapse, how are we going to govern my Synapse environment? How I'm going to secure the Synapse environment? Or working with Databricks, what are the security considerations, right? All of that we'll cover.
Mm-hmm.
So
Okay.
that maybe will give you a better understanding of not just utilizing the resources, but also what goes around the resource in terms of, managing it completely from governance to the tool to the security. That is obviously help you become a better architect, if you want to use the term, right? But eventually they're all
Mm-hmm.
data engineers.
Mm. Yeah. So do you cover or give us that difference between what data engineers do and what data architects do in terms of Azure?
Uh, Sorry, what was your question?
Uh, in the Azure world,
Mhm.
because I have seen job openings for Azure data architects as well and Azure data engineers as well. Um, so are you meaning to say both are same?
Not see 100% not same. So for example, a data architect, the responsibility for a data architect lies in designing the overall data strategy and the architecture, right? Creating the blueprint of how data will be stored, right? While the data engineer is the person who's responsible to build that architecture or to implement that architecture, correct? So for example, remove data part. You have Azure architect and Azure engineer, right? You have a cloud architect and you have a cloud engineer. The
Mhm.
role of the cloud architect is to make sure that a perfect infrastructure is created.
Oh,
Clear?
so I'm not talking about the cloud architect one. I'm talking about Azure data architect. So cloud
Yes.
architect, sort of they come from that infrastructure background. They set up all the, whole infrastructure in cloud and stuffs. They even sometimes do high volume data migrations at one go, this and that. I'm not going that line. I'm talking just the one you are telling
Yeah. So
designing.
so what I understand is you want to understand, how to define data models, how to do
Yeah, yeah,
quality
exactly.
standards, right? Security policies and all of that.
Yeah.
So yes, during conversations, we'll be covering those aspects, but the course is specifically for data engineering. We'll focus more on building the solutions rather than the governance and the quality standards and all those parts. We will talk about it, right? Eventually, it will come in the discussion that why is this particular thing better and why is the other thing not better, right? Why you should go for serverless SQL pool, why you should not go for, let's say, dedicated SQL pool in that particular case. So that is how we are going to have a discussion on it, not a dedicated section to discuss architecture. Yes, after each class, the complete recording of the class will be shared with you. All right. So the recordings
Hi.
will be
Hello.
present. Yes, go ahead.
This is Shakti. Sorry, just now I saw the message in WhatsApp. Just now it's joined, so that's why I'm missing the completely session. So that's the reason I
Yeah, yeah,
message.
we'll
Yes, Shakti, we will upload it by tomorrow morning. Don't worry. I will provide you the link as well.
Okay, okay, sure. That's why.
Yeah, yeah.
Please. Okay, thank you. So is it today's first class or is demo session? Or
Yeah,
today
this
is
is
more
demo.
like a launch session along with the demo.
so another doubt is that this Azure data engineering. So is it it's completely data brick is different or it's a different course or
It's
it is different?
no, no. Databricks is a part of data engineering on Azure. All right. Data
Oh,
engineering is a
okay.
broader concept. It involves a lot of tools. Databricks is one of those tools which we'll be covering.
This data brick including data.
I am not able to get what you're saying. Can you please type your question? Your voice is breaking.
I'm asking
No,
you
your
that
voice is breaking.
this ADF another is ADF is there data
Yes.
factory
Uh,
that
yes, that
also
is different.
different.
So these are all different tools. Synapse, Data Factory, Stream Analytics, Databricks, Fabric. These are all different tools that helps you with data engineering on Azure.
That's the fine, but I'm also a background of informatica background, so that's why I want to. So is it possible? So any pre-education is there?
Uh, if you know SQL and you know basic of Python, you're good to join this course.
No, I know SQL Unix also know, and also data warehousing concept, Informatica
Yes.
Power Center.
So
That
that
is
is going
my
to
primary three
help you.
tool.
Yes, that is
SQL
going to help
Server.
you. I think we lost him,
Yeah,
his
very good
voice.
depth knowledge of coding. Hmm.
Your voice
Sorry,
is not
actually,
audible.
I may not a
Yeah,
sorry. Just wait. I'm just coming to network area.
yeah.
Now is it fine?
Yes, yes.
Yes, hello. Actually, I'm a,
Yeah.
background of I'm a not a that good background of good coding. Like I'm a
Absolutely
like
fine. Absolutely fine. See,
it's fine.
people with Informatica background or any other data engineering background, they can definitely work with Azure, right? Their experience
So that's
with
why I'm a informatica because only what happened. I'm also not a I'm a work more than 5 years in a support profile in informatica
Mhm. Yeah.
along with SQL and Unix and informatica. So that's why is it prerequisite for me to learn or
As I said, SQL and Python are the only two prerequisites. Python, basics of it, we'll cover, right?
uh,
But eventually,
up
if
to
you want
OOPS
to,
concept I know, right? OOPS concept
mm,
I know. Then after
oops,
that yes.
yeah, go ahead.
Python, dear sir, actually Python I didn't learn anywhere,
It's fine.
but I know
The
SQL
basics we'll
Unix.
cover, but eventually, if you want to become a good data engineer, right, you need to have command over Python. That is something that I tell everybody. If you're not learning it as of now, if you've not started it, this would be a good time for you to start. And eventually, that is one of the most sought after skill, Python and SQL.
But it's
These two,
regarding this course, so Python is mandatory to learn.
it is mandatory to learn a certain tool, right? For example, Databricks will rely on Python, Spark Pool will rely on Python. Apart from that, the tools that we'll be covering, like Synapse, data factory, stream analytics, they do not require Python, right? You can create notebooks within them as an activity which will require Python again, but then again, they are not dependent on Python.
Okay, but actually, so what is the main prerequisite to before the learn this course?
As I said, SQL and basics of
SQL,
Python.
okay. Because
Yes.
I also know SQL, but I'm a like support background. So already more than 5 years I got experience in support profile. So that's the thing. So I'm not a development background. So I
That's
think
not a
that's why.
problem. Yeah. No,
Is
no,
it
it's
possible to
fine.
learn?
Yeah, it's fine. You can
Oh,
easily understand the concepts. It's not different, it's not difficult, and it does not require you to become or
then
to
I
be
think I
a.
thought that a lot of guys said there's a lot of coding is there, so it's very difficult. As a support guy, it's very difficult. So that's why I asked
No,
because
as I said, eventually, if you want to become a good data engineer, you need to know Python and you need to know a good amount of PySpark, or if you're doing Scala or you're working with Java, right? Eventually, Spark requires a lot of coding. That is where you will need to write a lot of code. But apart from that, when you work with Synapse, you're only working with SQL. When you're working with Data Factory, you are actually utilizing the no-code solution for data integration and data transformation. So data factory does not require any coding as per, right? So we'll
but
be
this
covering all
course
those topics.
complete data factory and data brick as well.
Yes, it's
Shakti,
Yes.
can you please reach out to me? I will explain you very clearly and I will give you the course content so that you know what are all the
Okay.
things he is going
Because
to cover.
why I'm
Yeah.
asked because I'm completely not aware this regarding course. So I lot of
Yeah,
notification.
understand. I understand. Please reach out to me. I will give you all the details and you can ask me even I can give you more details.
Okay. Okay,
Yeah.
sir.
all
Yeah.
right. We'll just
Mm.
give others also time to ask their questions.
I
Yeah.
just have one more. Is it okay if you guys can share your profile also?
Uh, we'll discuss with the backend team and let you know on that.
Okay.
Uh,
Hello.
Sorry, what is the question?
Profile of the trainer who is gonna conduct the training sessions.
Oh, okay. So I think you can inform the students, Shreyas, about yourself
Yeah.
because you
So
started directly
I'll
your training.
Yeah, I'll just quickly tell you about my past experience. So I have over 10 plus years of experience teaching Azure and Azure related certification courses to students. I have trained almost more than 70,000 students in the previous 10 years, right? So that is my profile. I worked extensively with students who are working on Azure administration, Azure security, networking in Azure, solutions architect on Azure, database administrators, data engineers. So these are the various courses, DevOps, the various courses which I have been teaching for almost now 11 years now, right?
So, Shreyas, my
Yeah,
one
Shreyas,
question.
I have one question.
Yeah.
Shreyas, how does QA or is can able to adopt Azure data engineering? Does any prerequisite is required, the things to be aware before entering into Azure data engineering, or everything it will get covered for a QA resource also?
See, as I told, right, it's very simple. What we'll be covering, we'll be starting from the very basics of cloud computing. So there is no prerequisite as such, but I expect all of you, because we'll be working with SQL a lot, right? Whether it is in Synapse, whether it is in even your stream analytics, we'll be writing our queries in SQL, and then even in Databricks, we'll be using the Spark SQL, right? So SQL is something that I want everybody to know. That is one of the only prerequisite that I would advise you to come with in this class. Nothing else.
Okay.
Uh, Shreyas, one basic question.
Mhm.
Like for ETL developers, what is the best like uh, future for whether it is data engineering or data analytics?
Can you repeat your question?
Uh, for ETL developers who are working at
Mm-hmm.
present, for them, what is their best future? Is data engineer or a data analytics?
All right, so you want to understand what is better, data analytics or uh, data engineering if you're coming from a ETL development.
ETL background,
Yes.
yes.
So see, obviously, the simplest answer to that question is that data engineering is generally considered better, right, career path than analyst, because ETL development is something which is the fundamental concept of data engineering, right? So since you have experience on it, if you already have expertise on it, why not build on top of it? Correct?
Okay,
Where you're focused on
great.
building and managing these data pipelines uh, to do the ETL process, right? And that also aligns with I think the broader responsibilities of a data engineer, correct?
Mm.
Whereas data
Yeah.
analytics, it focuses more on interpreting and drawing insights from the data, right? Which is a completely different skill set, in my opinion.
Oh, got it.
Yeah.
Hi Shreyash, I have
Mm.
one query. So, like, I have
Yeah.
been working with Informatica Power Center as the developer for past 5 years, and for
Mhm.
past 2 years, I have been working with the Informatica Cloud. So, like, shall I continue with Informatica Cloud, or like, shall I, switch to this Azure Data Engineering? Because I also see jobs related to IICS, but out of 100 jobs for IICS, I see 60 of them are asking for this Azure one. So as of now, like, I just want to know, like, which one, like, should I opt for? Like, shall I just opt this, or like shall I continue my learning path?
Yeah. So as I said, right, uh, Azure is something which is very high in demand, right? It has been adopted by almost all major companies, and you will always find more job opportunities when it comes to Azure, right? And as you said, if you're working with Informatica Power Center, right? You worked on it for 5 years, and that is still a valuable skill, right? But you can also learn to transition to Azure data integration tools like Data Factory, right? Which, in my opinion, right, and it can be biased, right? My opinion can be biased. I think that is a wise career move, right? As the industry is increasingly moving towards cloud-based solutions, especially considering the benefits of cloud, such as scalability, flexibility, cost efficiency that Azure specifically offers, right? The market demand for Azure, the technical aspects, scalability, cost effectiveness, right? Integration with other Azure services also, that makes Azure a very powerful tool and something which will be in demand, right? Higher compared to the other options which are available.
Okay, yeah. Thank you, Shreyash.
Yeah. All right. So we'll be taking more questions over the course, right, of today, tomorrow, and I think day after as well, in the demo class that we'll be having with all of you. So quickly today, we'll start with our concept, right? We'll start with a few topics that I wanted to discuss with you, right? So let me just share my screen. So this is where this course will start from, right? This is the first slide of the course, and obviously the last slide would be something in Databricks. Now, as you can see, we start from the most basic question. Yeah. So we start with the most basic question about what is cloud computing? What does cloud computing mean? What it offers, right? So in the simplest of forms, cloud computing is a delivery, I should say, all right, or a service that could deliver computing services to you over the internet, right? With zero human interaction, you can request for services. So cloud computing is the model that gives you these services, all right, that gives you access to these services, computing services over the internet, right? Now, various types of services are available. You have compute services. Compute services are services that require compute, right? In Azure, in data engineering, we'll be using this word a lot. Compute, you will hear everywhere, right? This simply means resources that require CPU, along with RAM, right? So any resource that requires compute can be a resource that requires CPU and RAM. Can you give me any example of a resource that you know about in Azure or in cloud computing that requires compute? Virtual machines?
Databricks.
You you build virtual machines? Databricks, yes. Databricks, uh, you can create the service without compute also, but to process data, right? To process data within Databricks, you need something called as a cluster, right? A cluster of computers that we call as nodes, right? So this cluster will require a lot of machines, right? So compute is required there also. In fact, uh, for data processing service, any data processing service, you will always require compute. In Synapse, this compute becomes data warehousing units. We call them DWU. All right. In your stream analytics, that becomes your DTUs, right? In your Databricks, it becomes DBUs. So these are all different compute units available in various data processing platforms. All right, so everywhere we will require compute. In Data Factory, we call it Azure Integration Runtime that provides the compute, right? So any resource that requires compute, you can create using cloud computing. Then you can create networking resources also, such as a virtual network. All right, virtual network is a networking resource. Similarly, firewall is a networking resource. VPN you can create in Azure, that is also a computing resource, right? So all of these different resources are networking resources available. All right, then you have storage resources. Storage resources such as data storage that we call as a storage account in Azure. Then there is data lake, right? There is a data warehouse, right? So various storage services and other services also which are related to storage. For example, there is Data Explorer, which can be used to work with the data. So in very short terms, cloud computing is a model that is going to give you access to various services over the internet, right? These services are computing services that are going to make your life easy. All right, whatever you can do with your system, right, which is present in front of you, you can do the same on the cloud, right? Whatever you're doing here, you can do the same thing on the cloud. You created a firewall in your local environment, you can create a firewall on the cloud. You created a VPN in your local environment, you can create it on the cloud. Then there are some other services also which I'm sure you may not have heard of. For example, Express Route. So in networking, we have a service called Express Route, which is nothing but building a dedicated connection line from your, let's say, data center, local data center, right, to Azure data center. So this is Azure data center, and you are creating a dedicated line of connection between your data center and Azure data center, right? You do so because you want privacy, you want security of your data, you don't want to send your data over the internet, right? So these are all different services that you create. App service. App service is a compute service within Azure. What is app service? App service is that service that gives you the ability to host web applications. All right, if I want to host web application in Azure, I can use this app service. This will also require some CPU and some RAM, right? Or you can just host static websites also, which do not require, but in general, app service will come with a app service plan that will require some amount of CPU, some amount of RAM. Creating virtual desktops, containers. These are all the services that will require some compute, right? So very simply, I can say that I needed a machine from Azure, right? Now this machine should be, let's say, 1 TB SSD, uh, 4 or let's say 8 cores CPU, 16 GB RAM. Yes. Now to create this virtual machine, if this is my requirement, something a virtual machine that I want to create on the cloud, right? Now, what could be the requirement where I need to create a virtual machine? For example, let's say uh, I'm working on creating an AI model, right? And I want to train my AI model, but my computer specifications are not enough, right? I'm not able to do so. I have very low RAM, I have very less CPU available, right? So the training is not happening efficiently. So what I can do, I can go to Azure over the internet and I can ask Azure, can you create a virtual machine for me with this particular configuration that will allow me to, this storage will allow me to store the training data and this compute will allow me to train my AI model, right? Or the machine learning model that I'm working on. Now to create this virtual machine, multiple things will be sent out. First of all, CPU and RAM will come from compute. Yes. Similarly, 1 TB SSD will come from storage account. Now, let's say this VM is created somewhere in US. It's a virtual machine. It could be created anywhere in the world, right? It is created over the internet. You access it over the internet. So the location does not matter, right? You do not have to physically be there. So this machine could be created anywhere. Now, if this machine is created in US and you are sitting here in India, how are you going to access it? To access this virtual machine, it should have a public IP address, right? This public IP address will get attached to a network interface card, something which we see in our physical machines. Your machines have a network interface card where you have the public IP, right? Then only I can connect to it. If this virtual machine needs a public IP, right? If this virtual machine has a public IP, then obviously it's a part of a network also. So that virtual network will come from the networking section. That public IP will also come from the networking section. Then a network interface card will also come from the networking section, right? So these are all your uh, resource providers, right? We call them resource providers. Compute is a resource provider that will provide compute resources. Networking resource provider will provide networking resources. Storage resource provider will provide storage based resources. Similarly, you have database resource provider that will provide you with databases, right? So that is it. Then we come to the situation where cloud computing was not popular. When cloud computing was not popular, right? When it was not used a lot, at that point, all the organizations, they had their own data centers, right? That is how organizations used to operate before cloud computing became popular. They all had something called as a private cloud, right? We also call this as an on-premise environment, right? On-premise environment or the private cloud. All the organizations relied on this. There was no cloud. They had to build their own data centers. These data centers were built in their own locations. They had to put in a lot of money to build these data centers because a lot of servers you would have to buy. You would have to buy a lot of storage devices, right? Creating a data center takes a lot of resources. A lot of hardware needs to be procured. So as an organization, now you have to pay for everything, all this hardware that will be used to create the data center. And data centers are very expensive. All right. Building a data center and managing it is a very expensive task. But the organizations were doing it, right? They had no option. There was no cloud computing available. So organizations would create a cloud environment in their data center, right? So they would create a data center within their organization, and the organization itself was responsible for operating the entire service, right? They had to manage their own environment. They had to manage everything: who will access, how they will access, what is stored, where it is stored. Everything their administrators would take care of. All right. And it does not provide any access to users outside the organization. So I believe some of you today may be working in organizations that still have their private clouds, right? A lot of service-based companies still have their private clouds running, right? And they're utilizing it because obviously they've put in a lot of money into it. They cannot just discard it and throw it away. But slowly and eventually, gradually, they are moving towards cloud computing, right? So private cloud was the initial solution. Private cloud is how all of it started, where organizations would create their own data centers within their own premise. That is why we call it on-premise systems also, or on-premise environment also. Then something changed around 2010, or around that time, something changed. Now what happened, and I'll just draw it out. There were few organizations. We'll take example of Microsoft. Let's say Microsoft came to India and they had very high expectations, right? They had huge plans, high expectations from the Indian market, and they started building their own data center, right? What Microsoft ended up doing was they created a huge data center in India, right? Let's say they created a huge data center, and then they realized that they are only utilizing 10% of it. All right. 90% of the data center is vacant. Clear? So you understand the problem here? They put in so much money to build a data center, but they did not need it. They were not using it, right? A similar situation would be that you have built a house which has multiple floors, right? This is your ground floor. This is your first floor, second, third, and let's say fourth, right? Now, let's say you are a family of 3 members, right? And the ground floor is sufficient for you. Sufficient. I don't need the first floor. I don't need the second floor. Now, to build this house, you put in so much of money, correct? How are you going to get some returns? Because if you put in so much of money, there has to be some return out of it. How do we get this return? What do we do? Whenever we make a huge investment, we are expecting of some returns out of it. So where will the return come from here? Any guesses?
By rents or else we can sell the flats.
You can
We can give them to rents, or also we can sell
rent,
them.
right?
Yeah.
You won't sell because you don't want to lose ownership of your own, let's say, house. So what do? You rent it out, correct? You will get some rent from here, you will get some rent from here, you will get some rent from here, you will get rent from here. So that will make some business sense, right? Why? Because you put in a lot of money, something that we call as capex. I will discuss capex and opex in a while, right? So you put in a lot of capital expenditure into building this house, but it's not generating any revenue for you, right? So you start renting it out, and that is what Microsoft also did. They started renting out this vacant space. They said we have a lot of servers available, storage available. Whoever wants to utilize them, we will build a portal for you, and you can access our data center over the internet, right? And you can create your resources here. So one company came, it took this much space of the data center. Now the company does not have to build its own data center. It can just utilize this existing data center, right? And all of it will be on rent. This rent is an hourly rent. It's not even a monthly rent or an yearly rent. It's an hourly rent. So you only pay for what you use. Very simple. You only pay for what you're using, and you pay an hourly rent for it. So if you just use the virtual machine for 5 hours, then you only have to pay for 5 hours. So this was the kind of cost efficiency which was being introduced now, right? If I need something for 5 hours, 6 hours, 10 hours, 15 hours, then I don't have to buy it, right? I can just utilize it for 5 or 6 hours, pay a minimum rent, right? For example, I'll tell you a virtual machine with the 4 cores CPU, 16 GB RAM, and 256 GB SSD storage. Can you guess the rent for this machine? Can you guess what would be the rent for this machine? The rent for this machine is around, I'll tell you in INR, that is 16 to 18 rupees, right? Somewhere between 16 to 18 rupees, depending on various factors. And I'm talking about a Windows machine where you have to pay for the Windows license also. So just by paying 16 to 18 rupees an hour, you are getting access to a machine over here, right? Which was really useful for organization, for our smaller organizations that don't want to put in a lot of money into building data centers, right? For a startup, building a data center could, take away all the funds that they have, right? So now they don't have to do it. They can just simply rely on these cloud service providers, and then they can utilize this. And this opened the gates for something that we call as public cloud. All right. So this was your public cloud, where we don't have to build our own data centers. Microsoft, in case of Azure, or Amazon Web Service, or Google, they would have built these data centers for us, and we're just going to use them, right? We're just going to rent it out, and that became public cloud, right? So when you had public cloud here, these are the cloud environments which are not owned by us. We are not the owners. We do not get access into the data center, right? If tomorrow you go to an Azure data center and you ask Microsoft that I want to see the server on which my workload is created, or I want to see the storage account in which my data is stored, they will throw you out, right? They will not let you enter. The only way in which you can access the data, all right, is over the internet. All right. So now the same data center could be used by multiple organizations and multiple, uh, you know, entities, and they will all have their own tenants on the cloud. We'll talk about what tenant is later on in the course, right? And people would be accessing this particular public cloud over the internet. So this became your public cloud, right? Now, anybody who was switching to public cloud, right? There could be a situation that beforehand they already had private cloud. Yes or no? There could be a situation that an organization was already using a private cloud and is now switching to public cloud. Correct? So in that case, that organization will have access to both the clouds, the private cloud also, the local data center that they have, and the public cloud also, the uh, cloud service provider data center that they have. So all of these companies are basically called as cloud service providers. Your Azure, AWS, Google, they provide you with this cloud services. So they are called as CSPs, cloud service providers. Now, a situation where a company has both its own data center also, private cloud also, and has presence on public cloud also, those organizations now have something called as a hybrid cloud, which is nothing but a combination of public and private cloud. Clear? Now, when it comes to an important aspect of cost associated with the different clouds, there are generally two types of costs. One called CapEx, called as capital expenditure, and second is your OpEx, called as operational expenditure, right? Now, CapEx, which is my capital expenditure, is a one-time cost, all right, or the initial investment that I do, right? For example, buying hardware. Now, once I have bought the hardware, I do not have to buy it again and again, correct? If I bought the servers, they will stay and I'm going to utilize those servers. So CapEx is not something that I'm going to, the cost for CapEx is not going to recur, right? So it's a one-time investment cost, it's a capital cost, right? And for example, buying hardwares, building the data center. For example, let's say the data center building did not exist and you constructed a new building. So that is also a one-time cost. You're not going to construct the building every month or every year, right? It's a one-time cost. Once it's done, right? So that is the capital cost. The one initial cost that you have to only pay once. Operational cost or the operational expenditure is the recurring cost, mostly monthly. Can you give me examples of recurring costs in a data center? Can you all give me a few examples?
Cost of running the machine like CPU.
So what is that cost? Cost of running the machines. It could consume electricity, correct? Electricity cost, internet cost, salaries to people who are managing the data center for us. Now, this is a recurring cost. Every month I have to pay electricity bills. Every month I have to pay internet bills. Every month I have to pay the salary, right? This cost does not stop. And then I have the cloud or the public cloud cost, I should say. Which is nothing but the rent, right? So I would not classify rent. It is an operational cost, right? Rent is obviously an operational cost, but when you compare the operational cost of private cloud and public cloud, there the private cloud will include electricity, internet, salary, all these things, whereas the public cloud operational cost will only be the rent that you have to pay for the services that you have used. And capex is something which is only available in private cloud, right? So if I now ask a very simple question to all of you present here, and with that we'll close the session for today and we'll continue from here tomorrow. My question is very simple. Which cloud model, the three that you have seen, public, private, and hybrid, which one do you think is most expensive?
On-premise, private cloud,
Yeah, private is the most
or it could be the hybrid also because it has both the cost.
Yes, absolutely correct. Hybrid cloud is the most expensive, right? If I want to compare the three types of costs that I've seen, capex, opex, and rent, right? The three types of clouds that I've seen, public, private, hybrid. In public cloud, do we have capex? No. In public cloud, we do not have capex. Why? Because the public cloud is built by the cloud service provider. Microsoft will build it, Amazon will build it, Google will build it, right? So I don't have to pay the capex cost there. I don't even have to pay the opex cost, right? When I'm using Microsoft Azure services, Microsoft is not going to ask me to pay the salaries, the internet bills, the electricity bills. No, they're only going to take the rent that is due, right? Based on the services that I have used. Coming to private cloud, do I have capex? Yes. If I'm building my own private cloud, I need to buy everything. I need to do a capital investment here. Do I have operational expenditure? Yes, I do. Do I pay rent? No. Coming to hybrid, which is nothing but a sum of public plus private. I have capex, I have opex, and I have to pay rent also. So which one becomes the most expensive one? Your hybrid cloud. Is this clear to everybody? Yes or no?
Yes, yes.
All right. So we'll stop here for the day. If you have more questions, we'll surely take them up tomorrow again. If you want to ask them now, we can discuss them now as well. But thank you everybody for being a part of this demo session. Tomorrow again we have a free session. I would request everybody to join in. All right. And tomorrow on top of the basics of Azure, we'll also demo a few concepts from Spark, right? So I'll just for the demo purpose, we'll discuss the basics of Spark and the Spark architecture as well. All right. So thank you everyone for attending today.
Having small
And
doubts,
I
Shreyas.
hope, yeah.
Shreyas, I have
Yeah.
one question.
What will be the cost of this course, entire course, Shreyas?
That you can contact the backend team. They'll let you know.
Okay,
All right.
sure.
For any subscription related details, you can contact the backend team. The WhatsApp number which
Okay.
is shared. Yeah. They'll communicate it with you.
Okay, sure. Thanks.
Yes, Shreyas.
Yeah.
So I have a
Hmm.
question. Like, how much Python required for this course? Do we need to learn whole Python or
No.
what is
See,
it? Yeah.
eventually it is not required, right? Why I said
Right.
is so that you know the basics of it, right? So when we work with sets, when we create sets and all, you have a basic understanding, right, of the Python syntax, very basic version of it. But eventually, as I said, right, eventually, if you want to become a really good data engineer, Python is something which is a must for you, right? For this course, we may not require a lot of Python, right? Because we'll be directly working with Azure services. We will discuss PySpark, but that is where each and every scenario that we want to discuss. I will write the code for you and I will explain the code for you, and I'll also share the sample codes for you with you. Right, so there you should not know something beforehand, but then again, in order to remember those codes, in order to remember the logic, Python is required. So
Yeah.
eventually
Yeah.
you will have to learn Python. There is no escaping that.
Okay. So do we need to learn any library like Pandas, NumPy,
Nothing
something?
required as of now. Just basic Python.
Uh,
We'll have a couple of session also on basics of Python. If you've not covered it, we'll be obviously discussing it in those classes.
yeah, sure, no problem. Yeah, thank you. That's all from me.
So Shreyas, tomorrow also we'll be having demo. Then after the day after tomorrow,
Yes,
the session will start.
yeah, and that is the plan. Yes.
Okay, thank you. Thank you.
All right then. Thank you everyone. I'll see you guys again tomorrow at 8 p.m. IST. Thanks everyone.
Thank you.
Thank you.
Thank you.
Thank you.